ರೆಕಾರ್ಡ್ ಡೌನ್ಲೋಡ್ ಆಗುತ್ತೆ ನೋಡಿ ಆಮೇಲೆ. So first you read the statement. First step, write the given data. Okay. A cylinder contains 1 kg of fluid. Okay. First consider one cylinder. So this cylinder has 1 kg of fluid. It may be air or it may be some liquid. Again, generally as given, it is fluid. So mass is equal to 1 kg. At an initial pressure of 20 bar. Okay. So tell me which value it is. Pressure. So P1, P2, P3. You have to tell like
P1.
that. Okay. Initial.
P1.
Initial means P1.
P1.
So it is in bar. You need to convert into Pascal. That is Newton per meter square. So what we need to do? Conversion bar to Pascal.
10 power 5.
Yes, 20 into 10 to the power of 5 Newton per meter square. Next, fluid is allowed to expand reversibly behind a piston according to the law PV square is equal to constant. So here there are many some words he has given. Okay, expand. This is one keyword you need to remember. Means the first process is expansion process. What type of expansion? It is PV square is equal to constant. And dear students, keep in mind, all processes may be expansion or compression. It doesn't mean that always expansion is polytropic, expansion is isobaric, expansion is isothermal. So for example, isothermal, if you take isothermal, this isothermal may be expansion, may be compression. If you take isobaric may be expansion, may be compression. In the previous two numericals, it was compression process, but here it is expansion. So what I do is, first I will write the process. Process 1 to 2 is PV square is equal to constant, and it is expansion. So what is the name of the process? Has he given name of the process? Whether it is isobaric, isochoric, isothermal, or adiabatic or polytropic. Which process is this? Process 1 to 2.
Isobaric.
No, it is not isobaric.
Polytropic.
It is polytropic. So on what basis you are saying or selecting that it is a polytropic? Always you compare the given equation with respect to PV to the power of n is equal to constant. Okay, here PV is there, value of n is 2, n is equal to 2. Compare this equation with this standard. Okay, so n is equal to 2, so it is polytropic process. If it is PV to the power of 1.4, then it is adiabatic process. Value of n will be considered as gamma, that is adiabatic process. Here it is polytropic process. So until the volume is doubled means during 1 to 2, 1 is initial process, second point number 2 is final process. Volume at end of the process V2 is 2 times of volume at the initial, means until volume is doubled. So volume at the end of the process is 2 times of volume at the beginning, that is initial. That is what it means. Next data you read. Fluid is then cooled. So this is one process. Next process, continuation is there. Process 2 to 3. The second process is cooling process. What type of cooling process? We'll see here. Cooled reversibly at constant pressure. Constant pressure. So cooling is at constant pressure process. What is the standard name for constant pressure process? Thermodynamic name? What you call?
Isobaric.
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 Yes, isobaric process. Okay. So second process is constant pressure process. What is the equation will you apply for constant pressure process? Constant pressure, again, dear students, always you remember this equation. PV is equal to MRT. Here pressure is constant means P is constant value. M is also constant and R is also constant. Only variable is volume and temperature. So V is equal to T. We can apply V is equal to T equation for constant pressure process. Governing equation, not work done equation. Work done equation is different. This equation will help you to find out volume. If the temperature is given, volume you can find out. If the volume is given, if you ask for temperature, you can find out using this equation. Same equation, if it is volume is constant, how will you write? Here I shown for pressure constant. If the pressure is constant, P is constant, M will be constant, R will be constant. Try to apply for volume constant. How will you write?
P is equal to T.
P is equal to T. That's it. If it is temperature is constant, all
PV.
three on the right hand side will be constant. Then
P,
will you write?
PV.
PV is equal to constant. Yes, very good. So these three equations will help you to solve some unknowns like pressure, volume, temperature, like that. Remember this equation. Okay. Next, third process, what he has said. Is there any data is given in the second process? Fluid is reversibly cooled at constant pressure until the piston regains its original position. What is the original position? V1 is original position. He has not given V1. So V3 is equal to V1. Try to understand what I'm saying. During second process, 2 is initial point, 3 is end point during second process. Okay. At the end of the second process, 3, what is saying? Until the piston regains its original position. Where it has stopped cooling process to original position, that is V1. I will draw the diagram. Okay, do not worry. I will draw the PV diagram also so that you will understand better. Okay, let me draw the PV diagram here so that you will understand easily. Okay, so pressure on y-axis, temperature, volume on x-axis. What is the name of the first process? Polytropic. Polytropic expansion. Whenever expansion is there, volume increases, pressure decreases. So you have to draw a expansion process starting from this point and expand downward. Why it is downward means P1 and P2. Here, compared to point number 1 and point number 2, pressure is decreasing and volume increases. So this is expansion. V1 is here, V2 is here. So the process begins at point number 1. This is initial volume for first process. This is final volume of the first process. And for the first, it is beginning point of the process. For second process, what he is saying, the cooling starts at 2 and end at 3. Okay, cooling starts at 2. Okay, here it is starting the cooling. Cooling means always volume decreases. Okay, cooling starts. Where will stop the cooling process? You have to stop somewhere, right? Where will stop? I will stop at point number 1 volume. Means why I have stopped here? This is initial volume. Point number 1 is initial volume. So V3 and V1 both are same. You cannot stop here. Okay, for the given numerical, we cannot stop here because at this point, it is not an initial volume. Initial volume is here. Vertical line, you have to draw one vertical line. So volume of the cylinder is here. That is what he has given. Next point. Heat is supplied with piston is locked in the position. What does it mean? Now from this point, they are supplying heat. Heating process is going on. One more process, heating process. From here, they are supplying heating. When you any process, when you supply heat, pressure increases. So I have to go upward, not downward. Because when you supply heat, for example, pressure cooker, when the pressure cooker is there, you are supplying heat, pressure inside the air, pressure inside the pressure cooker increases. Okay, so I have to go upward. Where will you stop? Will you stop here or here, here? Where will you stop? He has given on condition. Look at the condition, what he has given. Pressure rises to its initial pressure of 20 bar. Where will stop? The third process. Third process, you have to stop at initial pressure. Where is the initial pressure? P1 is initial pressure. So you have to stop here. So this is third process. So this is first process, second process, and this is third process. Have understood? Any doubts is there in drawing PV diagram? If you have any doubts, you can ask me. Do not hesitate. This is third process is vertical. So here, how many processes he has given in the process? There are 3 processes. Okay. So what he has asked, calculate net work done by the fluid. Net work done means total work done. Total work done is how much you need to calculate. And one data is given. What he has given? Initial volume is 0.05. Here I will write initial volume is 0.05 meter cube. This is initial volume. So initial pressure is given, initial volume is given. Okay. And any data is given. Yes, final some values they are given in the processes. So we have to calculate total work done. And dear students, how to calculate total work done? It is sum of all 3 work done. Total work done is equal to sum of first work done, sum of second plus third. Anybody could you tell me how to write W for the first process? Whether shall I write 1 to 2 or 2 to 1 for the first process?
1 to 2.
Yes. Why 1 to 2? Because always starts from initial point to final point. 1 to 2 plus next second process
2 to 3.
2 to 3. Next
3 to 2.
3 to
3 to 1.
3 to 1. So what will be the net work done? How can I write here? Any idea? 1 to where it is end?
3.
3 is not a end. It is a cyclic process. So I cannot write 1 to 1 like this. Initial point is also 1. Final point is also 1. We cannot write like this. If there is no third process, you can say 1 to 3. But this is a cyclic process. It is starting from this point, beginning point, and at the same point, it is ending. End process is also same. So I cannot write like this. So instead of this, what we need to write is WT. That's it. We have to write total work done WT. Okay. So now we will calculate individually. So W1 to 2. What is the expression for W1 to 2? Tell me. What is the equation? W1 to 2 is polytropic process. What is the expression for polytropic? We have discussed in the previous video lecture. What is the general expression for? First to tell me the equation.
P1 V1 minus P2
Yes,
V2 divided by N minus 1.
V1 minus
V1
P2 V2
minus
divided by N minus
N
1.
minus 1.
Now cross check which value is given, which value is not given. Okay, P1 is given. Yes, 20 bar, 20 into 10 to the power of 5. It is given. So I will write on the right hand side. P1 is equal to 20 into 10 to the power of 5. V1 is given as 0.05 meter cube. This is a Newton cube. This is a Newton per meter square. Has he given P2? P2 is not given, but V2 is given as 2 times of V1. Just look at here in the process 1 to 2, we have written as volume at the end of the first process, that is V2, is 2 times of V1. It is given. So I will write here V2 is equal to 2 times of V1. So 2 into 0 0.05, how much it is? 0.10 meter cube. So P1 we have calculated, V1 also you have calculated, P2 we don't know, V2 already you have calculated here. N, how much is the N value? N is 2.
2,
Okay, N is given. This equation you need to compare with this. Okay, I have shown it the arrow mark. N is equal to 2. I will write here. Now, how to calculate P2? Because P2 is unknown. Until unless I calculate P2, I cannot calculate work done. How to calculate this P2? Is there any equation is there you are seeing on the screen? What is the name of the first process and what is the equation he has given? PV square is equal to constant. This equation is throughout the process. We can apply this equation at point number 1. We can apply this equation at point number 2 also. So what we need to do is process. Okay, let me write here. Process 1 to 2 is PV to the power of square is equal to constant. So you are write this equation at point 1. P1 V1 square is equal to constant. Apply this equation at point 2. P2 V2 square is equal to constant. Simple. Right hand side, constant value. It is not 0, it has some value. So obviously left hand side should be equal. P1 V1 square is equal to P2 V2 square. Which is the unknown value? P2 is the unknown. So P2 is equal to P1 V1 square divided by V2 square. Substitute the value of P1. V1 also you substitute. Divided by V2 is 0.10 and it is square. Okay, some students in hurry they will forget to do the square. So P2 is equal to so much. Look at the diagram and tell me P2 should be more than P1 or less than P1. P2 should be more than P1 or less than P1?
less than.
Less than.
More than P1.
Less than or more than?
More than, sir.
Why more than?
Constant ಇದೆ ಇಲ್ಲಿ.
In constant ಇದೆ. You first we are calculating for the first process. You have to look at only first process. 1 to 2.
Polytropic.
Polytropic. Very good. So point number 2 is here.
Yes.
Yeah. Point number 1 is here. And origin value 0 starts from this point. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you tell me which value is more. P1 is more, P2 is more.
P1 is more, sir.
P1 is more. So P2 should be less than P1 for the first process. Correct? Okay. So if anybody doing calculation? If you have calculator with you, please calculate this answer.
3.
How much?
5, sir.
5.
5.
Okay. How much is the value of P1? 20, no?
5 into 10 to the power of 5.
5 into 10 to the power of 5 bar. Not bar, Newton per meter square. Okay. So substitute to P1, P2, V1, V2, any all values in equation number 1. So from this equation number 1, from equation number 1, W1 to 2, substitute all the values. I will not substitute P1, V1 here. You people substitute it and tell me the value. Okay, will you get positive or negative? Will you get positive or negative? On what basis you will decide whether positive or negative? Compression and expansion. For the compression, the value of work done will be negative. For the expansion, the value of work done will be positive because it is expanding. Volume increases. So because first process is expansion, he has given. Yeah, we have written here expansion. So work done should be positive. Due to some calculator mistake, if you got some negative value, assume that you have done something wrong. So how much it will be?
50,000, sir.
50. 50 into 10 power 3.
1000 joule or
Joule.
50 kilojoule.
Kilojoule.
Yes. Next. Second. What is the name of the second process? Constant pressure process. Here it is a constant pressure.
Isobaric.
So isobaric. What is the expression for isobaric? What is the expression for work done for isobaric?
P into
Very
volume final minus volume initial.
Oh, okay. Very good. So what should I write here? Process is 2 to 3. Process 2 to 3. So tell me, what should I write here? W2 to 3 is equal to pressure into yes,
final
V3 minus V2.
V3 minus V2. So not necessary to write final volume minus initial volume. That is what I saw for only for understanding. Here pressure is constant. How much is the pressure? Dear students, here will you take P2 or P3 or anyone is okay? Second process.
P2.
P2.
P2 or P3 or anyone is okay?
P2, sir.
P2. Why not P3?
P2 is equal to P3.
Yes, very good. P2 is equal to P3 here. It is a constant pressure, no? From this line, it is horizontal. So value is here. It is same at this point. The same value at this point. Correct? Okay. So P2 is equal to P3. You take any value. Any value. P3 also you take or P2 also you take. Anything is correct. So P2 is already you have calculated here. So I will substitute. Okay, do not get confused, sir. Why you have written P2 here? Okay, you can P2 or P3. So 5 into 10 to the power of 5 into V3 is, has given V3? Okay, now challenging. You tell me whether E3 is given directly or
V3 is equal to V1.
Yes.
To V1, sir.
Yes, very good. V3 is equal to V1 because it is a constant volume process. Here it is constant volume vertical line. Okay, so V3 is equal to V1. How much is the value of V1? 0.05. Directly I can write 0.05 minus V2. V2 is 2 times of V1. Dear students, now you tell me whether it is a positive or negative value. Here 2 to 3 is expansion or compression?
Compression.
Negative value, sir.
Negative value, correct. Negative value because it is a compression. Point number 2 is more than point number 3. This value is less than this value. So it is undergoing compression. So you should get negative value. Okay, 100% you will get negative value. Okay, by seeing the equation also you can say here. Here it is 5 paisa, 0.05, and here it is 10 paisa. 5 paisa minus 10 paisa, again you will get negative value. How much you will get? Maybe 25 something, right?
Yes, minus 25 into 10 raised to 3.
Minus 25,000 joule or minus 25 kilojoule, correct?
Correct, sir.
Correct, very good. So I will put one helmet for this, W2 to 3, one and square box, safer side. You have calculated. Next. What is the third process? What is the name of the third process?
Constant pressure.
Third process. Here, this one is third process.
Constant volume.
constant volume. What is the expression for calculating constant volume?
0, sir.
Very good. Do not scratch your head to calculate, oh, what is the equation? What is the equation? If it is constant volume, directly you write
Zero.
W321, directly you write 0. Why I'm getting 0? I will show you here. Okay, I will show you. Okay. So W321 is equal to pressure. Let us consider this equation only. Why I will get 0? P into final volume minus initial volume. Let us consider simple equation. Pressure, okay, some value will be given, multiply by final volume is V1. Initial volume for the process is V3. V1 and V3 both are same, 0.05, 0.05. 0.05 minus 0.05 is 0. So value will be 0. Okay, in sometimes we'll be using this equation in a second law of thermodynamics, V into dP. Okay, time yeah. So substitute all the values. So W1 to 2 you substitute, W2 to 3 and W3 to 1. Here you got 50 kilojoule. This one you got minus 25 kilojoule. The third one you got 0. So total net work done is 25 kilojoule. Any doubts? This is third process. Means there are three processes are there. This numerical includes three processes. They may give 4, they may give 2, they may give any 1. Okay. Individually you calculate the work done and substitute all the values. Any doubts?
No, sir.
No, sir.
Okay. So if you have any doubts, you can ask me. Otherwise, in the evening, what we do is based on students' request, they are requested to solve first law of thermodynamics numericals. We will solve, and when we will get back, if it's okay, we will start. Otherwise, no issues. A certain mass of air is